All right, so in this video, I'm not going to go through this next piece where we are looking at these calculator limitations. I will just briefly. I think I've written enough here as well, so hopefully it's self-explanatory. But in this box, and then in the continuation of that box on the next page, so really they're meant to be in the same box. I really just show you how you can take log base 2 of 13, and even if you have a calculator that doesn't have a logarithm with a different base option, right? Many calculators only have the log button and probably the ln button as well. So if that is the case, and you can't have different bases, then that's a perfect place to apply the change of base rule in a calculation. So log base 2 of 13, hey, can't calculate it because I only have the log button, so I can only calculate in terms of base 10. Well, just apply the change of base. Log base 2 of 13 is the same thing as log base 10 of 13 over log base 10 of 2. And I show you that here. And then log base 10 of 13 is 1.1, log base 10 of 2 is 0.3, and then you just divide those. Try to keep some degree of accuracy here, and that would roughly be equal to 3.7. What that means is if we raise base 2 to the power of 3.7, we'll roughly get 13. So I just show you some logic here on how you can double check whether that answer makes sense. I'll leave you to go through that. Let's jump to an example. So here we need to write each logarithm in terms of log 2 and log 7. So a hint here is that if we have something like log of 54, what we're going to want to do is we're going to want to expand this. And one way to expand this is to use the product rule. So what we can do is we can write 54 as a product. As a product of what? Well, ideally as a product of 2 and 7. Now, 54, if we factor this, it looks like we don't have a factor of 7 in here, and that might be my fault. These are notes that I typed up. So let's actually change this question. Let's change it to log of 56. There we go. Okay, so apologies for that confusion, but let's change this to log of 56. The goal is the same. The goal is the same here. We want to expand this using the product rule. So we have to write this input as a product. So log of 56. How do we write 56 as a product? So we're going to write the proper number here, 56. It's even, so we can divide it by 2. What do we get? We get... what is that, 28? And 28 we can divide by 2, and we get 14. And 14 we can divide by 2, and get 7. There we go. So we got factors of 2. Good. That's what we want. And we have a factor of 7. That's what we want. Good. So we expanded it using the product rule. What were we looking for? Well, we were looking for factors of 2 and factors of 7, which we found, luckily, because I was able to magically change the question here. Okay, so log of 56. I will first write this as log of, well, here I have 2 times 2 times 2, which would be 8. So all of my factors of 2 are trapped in this number 8 here. And then I have 7. So log of 56 is really log of 8 times 7. Hopefully that makes sense. Here I will apply the product rule. I'm just trying to be explicit about what step I'm doing here, what logic I'm using. So via the product rule, if I have a logarithm of a product of factors, I can just write that as the sum of the logarithms of each factor. And here I will just express 8 as 2 to the 3. Right. So log of 8 is really just log of 2 to the 3. Hopefully that makes sense. 8 is really just 2 times 2 times 2. All right, so then, and I also have this log of 7, which I shouldn't forget about. Then I can apply the product not the product rule. Sorry, what rule can I apply where I have an input raised to a power? That's the power rule. So I take this 3 and I just starting to look like a bit of a mess here. So let's use a different color. I can take this exponent of 3 on my input of my logarithm, and I can move that out front. So that's just 3 log of 2. 3 log 2 plus log 7. So this original logarithm has now been expressed in terms of log 2 and log 7. So this is your final answer. This is as good as we can get here. So hopefully that makes sense here. Now let's look at the next question. The goal is the same, so we want to take this logarithm and we want to express it in terms of log 2 and log 7. So again, we're going to have to expand this. Our goal is to expand. But it doesn't look like we can use the product rule here. So let's use the quotient rule. I mean, technically we could use the product rule on that 49, but because the 49 is really just 7 times 7. Technically, you can always be using the product rule, right? Because even if you have something like log of 7, well, 7 is prime, but you can expand this because this is really just log of 1 times 7, which would just be log of 1 plus log of 7. But it's silly to do this because log of 1 is really just 0, right? 10 to the 0th power is 1. Anyways, I hope that small caveat didn't confuse you further. But clearly it's the case here that it would be much more of an advantage to use the quotient rule because we have a quotient, a clear quotient in our input here. All right, let's use maybe green just so that we don't mix this up with the previous example. All right, so log of 49 over 2. Expand using the quotient rule. Well, the logarithm of some quotient is really the difference of the logarithms of the numerator and the denominator. So log of 49 minus log of 2. Now again, our goal is to write this in terms of log 2 and log 7. It looks like log 2 is taken care of. What about log 7 here? Well, let's work vertically downwards. Log of 49 is really just log of 7 squared. Okay, so we're one step closer here. And in time, it'll hopefully become clear that this is a perfect opportunity to apply the power rule. We have the input of the logarithm raised to some power. We can write that exponent as the coefficient in front of the logarithm. And there you go. This is log of 49 over 2 expressed in terms of log 7 and log 2. And this is as far as we can go. So in the next video, we will look at reorganizing other logarithmic terms and other logarithmic expressions. In fact, it's not just a reorganization that we're going to need to do. We're going to need to reorganize these for a specific purpose to find the exact value. So I will see you in the next video.